everyone, and welcome to my new video series, where I solve all, or as many as I can, of the British Maths Olympiad Round 2 problems from 1993 to present day. Let's start at the beginning, with 1993 problem 1, and stick around until the end for the maths problem of the day. We usually measure angles in degrees, but we can use any other unit we choose. For example, if we use 30 degrees as a new unit, then the angles of a 30, 60, 90 triangle would be equal to 1, 2 and 3 new units respectively. The diagram shows a triangle ABC with a second triangle DEF inscribed in it. All the angles in the diagram are whole number multiples of some new unknown unit. Their sizes ABCDEFGHIJKL, with respect to this new angle unit, are all distinct. Find the smallest possible value of A plus B plus C for which such an angle unit can be chosen, and mark the corresponding values of the angles A to L in the diagram. Okay, so let's set one unit equal to n degrees. Then A plus B plus C equals kn, where k is an integer, as A, B and C are all integer multiples of n. It's not hard to see that the problem is asking us to find the minimum value of k. However, we know that A plus B plus C is equal to 180 degrees, as A, B and C are three angles in a triangle. However, we also know that the sum of all the angles in the diagram is equal to 180 degrees times 4, which is equal to 720 degrees, and there are four little triangles in the diagram. Therefore, the sum of all the angles in the diagram is equal to 4kn. Now, since all of the angles in the diagram are distinct, to minimise this sum, we need to set all of the angles in the diagram to be some permutation of the first 12 positive integers times n, the sum of which is 78n. Now we can create a nice inequality here that 4kn is greater than or equal to 78n, as 78n is the minimum possible sum of all of the angles in the diagram. Now, dividing both sides of the equation by 2n, we get 2k is greater than or equal to 39. Now, the smallest possible positive integer for which this is true is 20, so we can set k is greater than or equal to 20. Now let's clear some space. Now, note that if we can correctly number all the angles in the diagram for k equals 20, then we will be done, as 20 is the minimum value of k. So let's set k equals 20 and see what happens. Now, one way of numbering the angles in the diagram, such that k equals 20, is setting them equal to some permutation of this set. And since k equals 20, the sum of these angles is going to be 80n, and the sum of the numbers in this set is also 80n. Now, let's set a equals 14n and see what happens. Then, b plus c is going to equal 6n, meaning that they're going to be some permutation of either 5n and n, or 4n and 2n. So again, let's set b equals 5n, and c equals n, and see what happens. Then, we know that g plus h will also equal 6n, meaning that g and h will have to be some permutation of 4n and 2n. So let's set g equal to 4n, and h equal to 2n. Now, where can 3n go? It can't go in triangle FDE, as then the other angle in the triangle will be equal to 12n, which isn't in the set. It also can't go in triangle CDE, as then the other angle in the triangle would be equal to 16n, which also isn't in this set. Therefore, it must go in triangle FDE. However, it can't go in position F, as then I would be equal to 13n, which isn't in the set. in position E, as then L would be equal to 15n, which isn't in the set either. So D must be equal to 3n. Now, let's turn our attention to triangle DEC. We know that K plus L is equal to 19n, meaning that K and L are either some permutation of 11n and 8n, or 10n and 9n. So let's set K equal to 11n and L equal to 8n, and see what happens. From here, it's easy. J will be equal to 6n, because the angles in a straight line will sum to 20n, while I will be equal to 9n, as again, the sum of the angles in the triangles will be equal to 20n. And then F will be equal to 7n, E will be equal to 10n, and we're done. Okay, now here's the math problem of the day. I actually have two problems of the day for you today, a medium one and a more hard one. So in the medium one, we need to find an alternate numbering of the angles in the diagram, where K still equals 20, and A, B and C are not equal to 14n. And now for the hard problem. Mr. A and Mr. B play a game. Mr. A goes first. So they choose an integer m and create a set of all of the positive integer factors of m. Now on each turn, someone gets to take an integer from the set. But when they take an integer from the set, they also have to take away all the multiples of that integer from the set. The person who loses is the person who takes the last number from the set. Determine which player has a winning strategy, with proof. Thank you for watching, and I'll see you all in the next video, where I tackle BMO2 1993, problem 2.